Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When an allylic or vinylic bromide undergoes ionization, loss of Br, it forms a carbocation that can be delocalized, allylic cation. Two different compounds yield the same carbocation if, upon loss of Br, the resulting allylic cation has identical resonance structures. Moving on to the next step. Analyze each structure. Structure A, 1-methylcyclohex, 2N6-vinyl bromide, or equivalently, the Br is on the carbon adjacent to the double bond, and the methyl is on the other carbon of the double bond. Ionization gives an allylic cation delocalized over the double bond carbons. Structure B, 4-bromo-1-methylcyclohex, 1Na. Br is at C4, which is not adjacent to the C1, C2 double bond. C4 is 2 carbons away from the double bond. This is not an allylic bromide in the classical sense relative to this double bond, so ionization at C4 gives a simple secondary carbocation, not the same allylic cation. Structure C, 6-bromo-1-methylcyclohex, 1Na, Br on the carbon adjacent to the double bond, on the opposite side from A but equivalent due to symmetry of the allylic system. Ionization gives an allylic cation delocalized over the same 2 positions as in A. Structure D, 1-bromo-2-methylcyclohex, 2Na. Br is on the carbon adjacent to the double bond, allylic. Ionization gives an allylic cation. Moving on to the next step. Compare carbocations from A and C. In A, Br leaves from C6, adjacent to double bond C1 is equal to C2, with methyl at C1. The allylic cation has positive charge delocalized between C6 and C2 with methyl at C1. In C, Br leaves from the carbon adjacent to the double bond on the other face side. Due to the symmetry of the 1-methylcyclohex, 1Na system, both A and C produce the same allylic cation. The cation delocalized between C1 and C6-C2 of the methylcyclohexanal system, effectively the same 1-methylcyclohex, 2N1 while 1-methylcyclohex, 1N6 cation. And for the final step. Why B and D fail? B gives a secondary carbocation not allylic, or a different allylic cation. D gives a different allylic cation, different substitution pattern. Therefore A and C both ionize to give the identical allylic carbocation, the 1-methylcyclohex, 2N1-vinyl, or equivalently 1-methylcyclohex, 1N6-vinyl cation, which is the same delocalized species. Therefore, the correct answer is C. Therefore, the correct answer is option C.